1995. In Bethlehem, Pennsylvania, the last blast furnace stopped. The stream of molten metal which had flowed for nearly a century began to slow. Then it stopped completely. This was a place where steel had once been made without interruption, where hundreds of thousands of people had once worked within the same industrial rhythm, a place where the furnaces had roared day and night hot enough to melt stone, now held only the sound of wind whistling through empty corridors. So what had happened when a system built to run without stopping no longer ran at all? Back to the moment when the first foundations of this system began to take shape. Charles Michael Schwab was born on February 18, 1862, in a small town in Pennsylvania, into a middle-class family of modest means. Schwab was not an outstanding student. He was not seen as a special talent, nor did he come from a technical background. But from an early age, he showed a different kind of advantage: the ability to connect with people and to make them believe in what he was saying. Schwab began his career from the lowest position. At 17 at Carnegie Steel Company, he took a job that paid $1 a day, driving stakes into the ground to mark positions for construction crews. After 6 months, he was managing a small team. In less than a year, he was put in charge of an entire department. By 1886, at just 24 years old, Schwab had become a manager at Edgar Thomson Works, one of the largest steel plants in the United States at the time. Andrew Carnegie, then the owner of Carnegie Steel, noticed him early, not only because of the speed of his rise, but because of something rarer. Schwab did not just understand the work. He understood how the entire system functioned. He could speak about the vision of expanding production while also understanding the cost of every ton of steel. He could manage thousands of workers while still maintaining the plant's operating rhythm. It was a combination of scale and practicality, of vision and control. By 1897, at the age of 35, Schwab had become president of Carnegie Steel, the largest steel-producing system in the world at that time. But Carnegie Steel still belonged to Carnegie. Schwab was the man running the system, not the man with final authority. He wanted more than that, not just the ability to operate a system, but the power to shape it. In 1901, Schwab played a central role in the biggest deal of its time. He persuaded John Pierpont Morgan to buy Carnegie Steel for $480 million, a figure worth tens of billions today. That deal led to the creation of United States Steel Corporation, the first billion-dollar corporation in history. Schwab became the first president of U.S. Steel, with a salary of $1 million a year, an unprecedented figure at the time. But differences in management style between Schwab and Morgan soon led to conflict. In 1903, Schwab left U.S. Steel. A year later, he arrived in Bethlehem, Pennsylvania, and joined the management of Bethlehem Steel, and gradually took control of the company. This time, he was not stepping into a finished system. He was beginning to reshape it. When Schwab arrived in Bethlehem, Schwab did not change the system one piece at a time. He shortened the distance between stages, or coal blast furnaces, casting, rolling, each was placed close to the next. Molten steel moved from one step to another with almost no pause. The plant was no longer a collection of separate parts. It became a system operating as a single flow. By the 1910s, the complex in Bethlehem, Pennsylvania stretched for miles, with multiple blast furnaces, foundries, and rolling lines operating at the same time. Rail lines ran directly into the plant. Raw materials entered at one end. Finished products came out at the other. As the system began to run more smoothly, Bethlehem kept expanding it more blast furnaces to maintain the flow. Longer lines to reduce waiting time between stages, tighter links between one section and the next. The whole operation functioned as a closed structure, almost like an industrial city. Each expansion did more than make the system larger. It made every part inside it more dependent on the rest. The system was beginning to bind itself to itself. In the early years of the 20th century, steel demand rose sharply, not only for railroads and bridges, but increasingly for war. When the First World War broke out, steel was no longer being demanded mainly for civilian infrastructure, but for weapons, warships, and armor plate. Bethlehem Steel Corporation became one of the major suppliers of heavy artillery, armor plate for naval vessels, and metal structures for the military. At that point, the system was operating with almost no pause. The blast furnaces ran day and night. The flow of steel kept moving from one stage to the next. Tens of thousands of workers filled each shift, one giving way to the next. Steel output reached millions of tons a year. At that moment, the system and the world around it seemed almost perfectly aligned. The larger the scale became, the more it worked to the system's advantage. And it was no longer just a factory. It became the center of an entire region, a place around which the city itself expanded, with worker housing, schools, and hospitals taking shape around it. But that alignment did not last forever. The world began to change. It was no longer about operating at the largest possible scale. It was about producing more flexibly at lower cost. New systems began to appear, smaller, less interdependent, able to stop, adjust, and then start again. A system built around blast furnaces could not operate that way. To keep the steel flowing continuously, the temperature inside had to remain above 1,500 degrees Celsius. Once a furnace cooled, restarting it did not just cost time and energy, it could also damage the refractory structure inside. Bethlehem was not only designed for continuous operation, it was bound by that requirement. And when new production models began to appear, smaller, more flexible, more responsive to market demand, the difference no longer lay only in technology, but in the way the system itself was built to operate. Bethlehem kept its core structure intact, not because Bethlehem failed to see what was happening, but because any change inside a system like this would pull on the blast furnaces, the production lines, the rail links, the labor force, the contracts, the city around it, and an operating rhythm accumulated over decades. Among the hardest things to change, it was not only the machinery, it was the people. During the years when Bethlehem was still expanding, the workforce was not just one part of the plant. The workforce was the foundation that kept the system running through each shift, each day, each year. Wages, benefits, pensions, agreements with the unions. All of it had been built in a period when output was still rising, orders were still strong, and the furnaces were still lit day and night. But when the world of steel began to change and orders began to fall, those commitments did not disappear. Labor costs, benefits, and pensions remained. And it was not only labor. By the 1970s, energy costs were rising sharply. For a system that depended on heat, electricity, transport, and continuous production, every change in energy prices went straight into operating costs. Bethlehem could not simply make itself smaller. A smaller plant could slow down, shut part of a line, and wait for orders. Bethlehem had to keep the rest of the system running. Every decision to cut back led to a larger question. Where could anything be cut without throwing the whole structure out of rhythm? They kept the existing system in operation. Costs were reduced where they could be. Changes that were too large were delayed. More time was bought where possible. But the distance between Bethlehem and the newer models kept growing. Smaller plants entered the market with lower costs, fewer obligations, and a faster ability to respond. Bethlehem still carried the full weight of a system built for an age of high output. The pressures began to layer on top of one another: labor costs, long-term benefits, energy, aging equipment, a production structure that was difficult to change. By this stage, the problem was no longer recognizing what was happening. The problem was that there was no easy way left to change it. When the system was no longer easy to change, the pressure began to show more clearly in the numbers. In 1982, Bethlehem Steel reported a loss of roughly $1.5 billion. The company suspended most of its steelmaking operations, and rounds of restructuring continued through the years that followed. From that point on, the decline no longer existed only in financial reports. It began to show in the plant itself. Orders fell, output fell. Parts that had once operated together began to be reduced one section at a time. And in a system built to run continuously, each reduction was not only a loss of scale, it was one step closer to stopping altogether. Each section of the complex was scaled back. Lines that had once been linked together no longer moved in the same rhythm. The workforce steadily declined. A system that had once been built to operate as a continuous flow was now being broken into pieces, becoming increasingly fragmented. By 1995, the C furnace, the last blast furnace at Bethlehem, had shut down. About 1,800 workers lost their jobs as the furnaces went cold. The blast furnaces stood still. The rail lines inside the plant no longer carried material through each stage. Areas that had once been lit through the night returned to darkness. The flow of steel that had continued for nearly a century did not continue any longer. This time it was not a temporary stop for repairs, not a pause between two production cycles. It was the end of the system that had built this city. A system built not to stop had finally stopped. But when that system stopped, it did not disappear alone. For nearly a century, Bethlehem Steel did not only make steel, it created a rhythm of life. The shift whistles, the roads leading to the factory gates, meals prepared around the hour a shift would end, families across generations, passing through those gates one after another. When the blast furnaces went cold, the city was still there. But the part that had once kept it in motion had gone quiet. It was not only jobs that disappeared, it was the stores that lost their regular customers, the neighborhoods that no longer woke to the sound of the mill, the people who had once measured time by the shift and now had to live by a different measure of it. Bethlehem did not become a place without life, but life there no longer turned around Bethlehem Steel. The steel structures still stand. The rail lines still lie inside the old grounds. The blast furnaces still look down over the city, only they are no longer used for production. They became silent witnesses to a time when an entire city once moved to the rhythm of molten steel. And perhaps what remains in the end is not only a set of old steel structures, but the trace of a system so large that it had worked its way into how people labored, waited, provided for their families, and believed in tomorrow. When something once mattered so much that it became part of the breath of daily life, how do people continue in the silence it leaves behind?